Okay guys, so after looking at the videos on interest rates and compound interest, we're going to start making some exercises on how to use different formulas from Excel that will allow us to understand what is the future value of an investment or even understand the payments of a loan. So let's begin with a very simple exercise we have over here, and we're going to talk about the time value of money. So the first problem says, what will a deposit of $4,500 at 10% compound semi-annually be worth if left in the bank for 6 years? So imagine that you have $4,500 and you are going to get a 10% interest rate, but semi-annually. And this is something that we need to understand. There are several ways to understand interest rate. It can be annually, it can be semi-annually, it can be monthly, or it can even be quarterly. So in this case, we have to change a little bit the formula. Okay, so let's see how much money this will be if left in the bank for 6 years. Okay, so the formula that we're going to use in this case is called future value. Future value has several parameters, such as the rate, the number, or the periods. We have the PMT, which is the payments in case that we make regular payments to that investment. We have the initial value, okay? And we have the type. The type, remember, it's if it's at the beginning or at the end of the period, okay? So let's start with the rate. Since this case is compounded semi-annually, what we do is that there are 2 periods every year, okay? So it's every semester. So what we're going to do is that we're going to grab the 10% interest rate and divide it by 2. So in this case, it's 5%, okay? Now the number of periods would be 12 because the number of periods would be 12 because it's 6 years, and 6 years will be 12 semesters, okay? So in this case, we make sure that our periods are 12. There are 12 every semester, okay? Now the monthly payment is 0 because we're just gonna let the money just sit there in the bank for 6 years, okay? So it's not gonna mean anything. We're not gonna put more money. We're not gonna invest every month. We're just gonna let it sit there for 6 years and see what we get. So it's 0. Now the initial value, okay, is the money I'm putting at the beginning of the investment, which is $4,500, and what we're going to do is that this is going to give us or capitalize us every end of the period. So I'm going to put 0, and here I get $8,081 at the end of 6 years. So at the end of 6 years, after putting this money, I'm going to get this, okay? It's not bad since you haven't done anything, but it's 6 years. So this is what the money is worth at the end of 6 years. Let's see another example. What will a deposit of $4,500 at 7% annual interest? So as you can see, it changes now. The annual interest is not semi-annual. So I won't have to divide 7% divided by 2 because it's annual. It's times 1. Okay? Annual means 1. Semi-annually means 2. And monthly means 12, so depending on what we get. Be worth if left in the bank for 9 years. So in this case, the formula will change a little bit. So let's just modify this. Now it's 7%, and since it's annually, it's just 1. And the payments every month is 0. We're just gonna let it sit there. And we also have $4,500. And in this case, so what we're missing, that the number of periods now, it's 9 because it's going to be 9 years, okay? So it's 9 years that we're going to leave it there, and we are going to get $8,273. So it's very simple. We just need to understand what is the type of interest rate. We see it semi-annually, then the interest rate will be divided by 2. Annual interest rate is divided by 1, okay? Or multiplied by 1. I'm sorry, divided by 1, divided by 2. And if it's monthly, it will be divided by 12, okay? So let's do the third one. What will a deposit of $4,500 at 12% compounded monthly? So in this case, it's 12. Now the interest rate, it's 12 divided by 12 because it's monthly. So it would be 1% interest rate. And then I have the number of periods, which is 10 years. Now, since it's compounded monthly, 10 years would be 120 months, because that is the period that I am doing it right now, okay? This is 120 months, and it's 1%, okay? The idea is that the number of periods, it's equivalent to the interest rate, if it's monthly, if it's semi-annually, or if it's annually, okay? Also, the payments are 0, and we have, I think, the same deposit, which is $4,500. In this case, after 10 years, I will have $14,851. Okay, so that would be B. 10 years, we're talking about 10 years of just letting the money sit there without doing anything. So that is not the idea if you are making an investment. The idea is that you actually make some payments and you'll see the difference, okay? Let's see number 4. How much will 1,000 deposited in a savings account? You guys understand that savings account don't give you a lot of profits because the interest rate is very low. An annual interest rate of 6% be worth at the end of 5 years. Okay? So let's see. We have 1,000 deposited at an annual interest rate of 6% be worth in 5 years. So we do the formula again. Just future value. What is the future value of 6%? Now the number of periods is 5 years. I'm not going to make any payments. The first value, or I'm going to start with $1,000, and then I'm going to get at the end of those 5 years, just putting $1,000, $338. That would be my earnings. Okay. Now let's look at number 5. Let's see, how much will 1,000 deposited in savings account earning a compound annual interest rate of 6% be worth at the end of 3 years? So it's just pretty much the same thing. We just change it for 3 years. Let's see at number 6. 6, it's a little bit different. Here we are giving an annual opportunity cost. Let me explain what is the annual opportunity cost. Here is a video that we are going to watch before we continue of what is opportunity cost. Okay, so I would like you to see this video before you continue. Okay, now that you understand what is annual opportunity cost, what is the future value of those of $1,000 ordinary annuity for 10 years? Ordinary annuity, you can see it over here, is a series of equal payments made at the end of a consecutive periods over a fixed length of time. So it's just the payments that you're going to get, fixed payments over a period of time. So it's saying you're going to get 1,000, the value of 1,000 ordinary annuity for 10 years. What would be that opportunity cost? What money are you going to get if you actually pay $1,000 every single for every single year during 10 years? Okay, now in this case, let's go back to our formula of future value. Now the rate is 10%. You have a 10% rate. The number of periods in this case is 10 years. Now the payments, and here it changes a little, it says that ordinary annuity is when you make $1,000 payments every single year. So every year I'm going to deposit $1,000, but my initial capital, or the first value that I have, is 0 because I'm starting with 0. And finally, I'm going to see what I'm going to get at the end of those 10 years. So at the end, just making a year deposit of $1,000, I'm going to get $15,000 at the end of the year, okay? So it's not bad, but in 10 years, your profit will be only $5,937, saying that you will deposit $1,000 every year, okay? So what we want to do is that every time that you invest money, you want to invest having a payment and also adding to that payment your interest and the time, because you want you want to start with capital. Start with a capital and see what that money is going to grow up to. Okay, that is a little bit different. Okay, making deposits will help a lot. Okay, why don't we, if we make a comparison between just letting the money sit there and just actually investing every month or every year, the money will be, you will see the difference. Okay, now let's look at number 8. If you require a 9% annual return on your investments, you're saying that you require that you get in return a 9% of whatever you invested. This is something that is done very regularly in business, is that you want some percentage at the end of the year, unless and decide if it is viable or not, your business. You would prefer, now the question is, you would prefer 15,000 5 years from today rather than an ordinary annuity of 1,000 per year for 15 years. And here is this is something that is very, very applicable to real life situations. What would you prefer? You want 15,000 at the end of 5 years, or you would like to get 1,000 per year during 15 years? Okay, so let's see the difference. Okay, so in this case, what we are looking at is the present value. Now we're not going to use the future value, but we're going to look at the present value of the formula. It says that if you require 9% annual return on your investments, you would prefer this money is at the end. This is what you're getting at the end, 5 years from today, rather than an ordinary annuity of 1,000 per year for 15 years. So in this case, what we're going to do is that we're going to find the present value, okay? And let's see what are the earnings. What would be the present value in this case? So we're talking about a 9% rate for a period of 5 years with no payments, because we're just going to let it sit there, and the future value is $15,000. In this case, I am going to get some earnings for $9,748. Okay, in this case, if I just receive the $15,000 at the end of the 5 years. Now let's look at the other case. In this case, let's find the present value of a 9% interest over a period of 15 years, making payments every year of $1,000, and understanding that the final value is what is when it gets to 0, is that where the payments have been done in this case, because I want to know what would be the present value of that money. Okay, in this case is 8,000. So here are very life-changing decisions. What would you prefer? $15,000 at the end of 5 years, or give you $1,000 every year for 15 years? This is here's where you see what is the profit of each of the things that you need. Okay, now let's look at the following exercise. How long does it take for 5,000 to become or to grow into 6,724 at a 10% compounded quarterly? Remember that I was saying that quarterly means divided by 4, okay? It means divided by 4. This case, how long would it take for this money to become this? And this is very common for you guys that want to start saving for your university, or your parents start saving for your universities, okay? So how long would it take? Here we're going to use a new formula. Okay, so now we're going to use a formula to find the number of periods, okay? So how many periods, or how many quarters of the year actually we need to do. So first of all, we need to divide 10% divided 4, which is quarterly. Remember, there are 4 quarters in the year. So we're going to use a formula called P duration, which returns the number of periods required by an investment. Now the P duration requires the rate. Now the rate is 10 divided by 4 is 2.5%. Now the present value is 5,000, and I want to know how long it takes to become $6,724.44. Okay, and here I get 11.9999. So pretty much rounding up, it's 12 periods, 12 quarters. So in this case, 12 divided by 4 will be 3. So it will take 3 years for this money to gain pretty much $1,724 at this interest rate. Okay? So it's interesting how money is worth and how we can define different aspects of our investment. Okay, our next exercise is also very common, and we use it also for loans. We use the payment formula, okay? So this is the question: how much must you deposit at the end of each year in an account that pays an annual interest rate of 20%? If at the end of 5 years you want to have 10,000 in the account. This is very normal. This is something that you would like to do in your business and project what is the money that you would like to have. So in this case, we're going to use the PMT formula. The PMT formula, it makes sure that you find the payments. Okay, you find the payments for a period of time and see what you get at the end. So how much must you deposit? We're talking about 20% interest, 20% every year for a period of 5 years. Okay, now the initial payment, or the initial money, you don't have a down payment for this. You're not going to start with a down payment. You're just going to start with $0, and the final value, you want it to be 10,000 at the end of these 5 years. Okay. So what you need to do is that every single year you need to deposit $1,343. Okay? At the end of 5 years, you will have $10 if you deposit every year $1,343. Okay? Now you can turn this into monthly, okay? If you have your monthly payments and you know that is your interest, okay? That is what is your interest monthly, you can do it the same way. Okay? This is interesting for the work that you have to do. Okay? I think we're good for now. And your job is to go to our Schoology website and look at the other exercises that I have for you. Okay? So you can do them, and probably in our currency. This is gonna help you visualize how the money you're going to use for your investment look like, and pretty much how you're going to pay your loan to the bank. Okay?